But I'd like to introduce Melissa Wilson as our next speaker. Melissa is assistant professor and manure management specialist at the University of Minnesota Department of Soil, Water, and Climate. And today she will be presenting manure, nitrogen, and phosphorus crediting. So welcome.
All right, can you all hear me okay? Do I sound muffled? There's a few speakers that sounded a little muffled. We good? All right. So my name is Melissa. I'm at the University of Minnesota. I'm the manure management specialist. And I want to talk a little bit about some of our research that we're wrapping up on manure, nitrogen, and phosphorus crediting. First, I want to talk a little bit about some of the nutrient trends we've been seeing. I actually got a hold of a bunch of different labs in Minnesota and asked if they would mind sharing their manure nutrient data. And 3 actually replied and shared their manure data with us, which was great. So I have data that I'm going to show you here from 2012 up to 2021. I believe we did get some 2021 numbers or 2020 numbers recently. So I want to show you a couple different things. We broke out the data into different nutrients. So here we have a swine liquid manure. The first kind of circle that's dark red is the total nitrogen amount in the manure. The lighter red diamond is the total ammonium. So this is the portion of the nitrogen that's plant available right away. The yellow triangle is the amount of phosphorus as P2O5, and the amount of potassium as K2O is in the gray square. Then you'll see these different bars that kind of extend out of each of these. So each symbol shows you the average number or the median value. And then the bars show you the middle 50% of all of the samples. So this is what's considered the inner quartile range. But basically, if we took all the samples and figured out where the middle 50% of all of them was, this shows you what that looks like. So it's a pretty good average of what kind of nitrogen and phosphorus and potassium values you can expect in swine manure, in this case, in Minnesota. So the y-axis shows us the different nutrient contents in pounds per ton if it's a solid manure, or pounds per 1,000 gallons if it's a liquid manure. And then I have different types of manure here. At the bottom, you'll see the number of samples that this represents. So this first one is 49,000 samples. Here's poultry solids, beef salad, and our dairy liquid. Now these 4 that I'm showing you here have the most samples of all of the different categories that we have in the different manure types. So I also have dairy solids, beef liquids, etc. But these kind of show us the most number of samples that we have across the state. So these are the most likely to be sampled. So again, we have the same pattern with different nutrient types within each of these. One of the things you probably notice right away is that liquid swine and poultry solid tend to have higher nutrient content per unit of manure versus our beef and dairy. They tend to have lower nutrient content per unit of manure. Doesn't mean that these are worse types of manure. It just means you have to apply higher rates of these to get the same nutrient content as compared to poultry solids and swine liquids. Another thing that I want to point out is if we're just looking at nitrogen, so the first 2 symbols within each of these graphs, wherever we have liquid, the ammonium content is a much higher proportion of total nitrogen. So in these cases, it's roughly half or so. And if you look at dairy liquid, the ammonium is about half of the total nitrogen as well. That's in contrast to poultry solids, which you can see that ammonium content is much, much lower compared to total nitrogen. And same with beef solids. In fact, the ammonia levels are very, very low, almost non-existent in these beef manures. So one of the reasons why I like to show this data is, one, especially with the poultry and swine, where we have some of the most or highest number of samples, you can see a really large variability across different farms in Minnesota. So this is really important when you're thinking about nutrient application rates, Because if you, for instance, if you have a swine liquid and you think you have 60 pounds of nitrogen per 1,000 gallons and you base your nitrogen application rate on that, but you only actually have 30, about half of what you expected, you're going to underapply nitrogen. And it's the same if you have the opposite, right? If you have lower nitrogen or expect lower nitrogen but have more nitrogen, you're going to overapply your manure. So it's really important to think about sampling your specific operation, because we do see sometimes even within like different barns within an operation, we might see differences in these nutrient contents. We also see differences as people change their operations. For instance, if we've seen when people are moving from dry feeders to wet dry feeders in hog barns, their nutrient content actually drastically decreases. The nutrient content increases because there's less water that ends up kind of in the manure. There's all kinds of different things that are going on. So anytime a big operation change happens, whether it's feed or you're changing how you're feeding, those sorts of things, it might be really important to get manure tested again. So that's another kind of thing that I want to point out here is looking at the phosphorus and potassium concentrations as well. You can see that it's really, really high in poultry solids, kind of called poultry manure. It's hot stuff. It's got all of the nutrients. And you'll notice that these are all pretty similar levels. Nitrogen, potassium, and phosphorus are all pretty close to one another. But, plants need different ratios. Usually they need a lot more nitrogen than they need phosphorus and potassium. So even though these nutrient sources have all the nutrients you need, they're not necessarily in the ratios that you want when we're thinking about maximizing the nitrogen and the phosphorus as much as we can. But it's also good to know what these ratios look like. For instance, dairy liquid, the nitrogen to phosphorus ratio is a little bit higher than it is with beef solids. So it's important to think about that as you're thinking about these high fertilizer prices and where to get the best bang for your buck. If you have manure, you want to try to get it out where you need more phosphorus, especially where we have more phosphorus to nitrogen ratio. So I always like showing that data to kind of reiterate the need to test manure fairly regularly. And you can tell that swine liquid, there's a lot of tests that have come through the state. So swine producers are doing a pretty decent job at testing their manure, but it looks like we could do a little bit more work on some of these other species. So it's not always just about how much nitrogen or phosphorus or potassium is in manure. It's also how available is it? Because we know that it's a mixture when it's found in manure, it's mixed between organic forms and it's mixed between plant available forms. So we have to think about how those organic forms that are not plant available right away release over time to provide the nutrients that we need. So we've done some research on some of these manure availability factors. I want to start a little bit with like the history of where we started from. So back in the 1990s, there was an effort to start looking at manure as a nutrient resource and trying to figure out how can we use this as a resource rather than a waste. So some of our manure availability factors were generated back then, and they're based on the total nitrogen and phosphorus content of the manure. And they're also averaged over manure types and handling systems, considering like liquid versus solid. Here's kind of a summary of what this looks like. Currently today, these are our current guidelines for determining nitrogen availability. We have beef, and then it's year 1 availability and year 2 availability, dairy, swine, and poultry. One of the main things that affects how much nitrogen is available is the ammonia content and how you incorporate the manure. Because if you leave manure on the surface, and the longer you leave it on the surface, the more volatilization or nitrogen loss you're going to get. So that's why you'll see where we have injection, which could be sweep injection or knives, discs injection, some way of getting the manure into the soil as you're applying it, will have the highest nitrogen availability, followed by incorporating the manure as soon as possible. So whether it's immediate incorporation with like double discs, or whether it's incorporating it within 12 hours, just coming through with a plow afterwards, that will generally also have high nitrogen availability. But you can see as we get like 12 to 96 hours, which is half a day to 4 days after applying it, you have less nitrogen available. And then up to 4 days, or incorporating it after 4 days after it's applied, it's even less nitrogen. Then our second year availability, you notice that is actually the same regardless of how it was applied. That's because this is just accounting for the organic portion that should release in that second year. That's why the second year doesn't really matter how you applied. It's more about how quickly we think that organic matter is going to degrade into the nitrogen that you need. So some of the things you probably noticed with that is that there wasn't a difference between liquid and solid, even though we saw differences between liquid and solid in our nutrient data. And it didn't seem to matter what we were talking about, like a swine finishing barn, a swine sow barn. It was all just considered swine. So we know there's differences, and we think that on top of the differences that we're seeing in new technologies, as well as what's going on with the changing weather patterns where it's getting wetter and potentially having more losses, we wanted to see if we can update or if these nitrogen release factors needed to be updated. So we started an experiment back in 2018. You can see kind of a diagram of what we had going on over here. We had two sites, Waseca, Minnesota at the Southern Research and Outreach Center, and at Lamberton, Minnesota, which is the Southwestern Research and Outreach Center. And we had two sites at each location. So we started one in 2018 where we applied 6 different types of manure and a couple different fertilizer rates. And then we also started a second site in 2019. The idea was that if we applied manure in different years, hopefully we get different weather conditions. Unfortunately, we didn't. Both were like the wettest years on record in a long period of time, and we'll talk about that later. We were hoping to maybe get a dry year in there, but we did want to see if we can get different conditions in each year. We had applied 6 different types of manure. We did a liquid swine finishing manure, a bedded beef pack, a raw dairy manure. We also had a separated dairy manure coming from the same barn. We had the raw before separation and the separated liquid afterwards. We had a turkey litter from a commercial barn, and we had composted chicken manure that you can get from a commercial or from like a Home Depot or something like that. And we wanted to compare all of these. Using our current recommendations, we wanted to apply 140 pounds of nitrogen per acre, because this was following soybeans. So that's why we chose that rate. Then we applied fertilizers. We did a nitrogen response rate. So we went from 0 up to 120% of nitrogen needs for that corn. And we also did separate plots where we had a phosphorus rate curve from 0 up to 120 pounds of phosphorus. The idea was that if we compared our yields and nitrogen and phosphorus uptake of the manured plots to the fertilized plots, we could get a good idea of fertilizer equivalence value. This just gives you a summary of what we did in years 1 and then years 2 and 3. The full nitrogen rate was considered to be 140 pounds of nitrogen per acre in that first year because we followed soybeans. Manures were applied at a full rate. Our nitrogen fertilizers were applied. We also applied full P, full K, full sulfur on those plots. For our phosphorus plots, we had phosphorus rates changed, but full nitrogen, full potassium, and full sulfur were applied to make sure that only phosphorus was limiting potentially in those plots. Then the second year, we did not apply manure again. We did not apply any nitrogen or phosphorus to those plots either. We just applied potassium and sulfur. Again, trying to make sure that those nutrients weren't deficient. They wouldn't cause yield limiting issues. Only phosphorus and nitrogen would potentially cause those issues. Then we, again, with our fertilizer plots, we applied the same nitrogen rate curve and same phosphorus rate curve. The phosphorus rates were in fact the same. Nitrogen, we did change a little bit because the full nitrogen rate in the second year was 195 pounds of nitrogen. Because in this case, we're following corn on corn. So we upped the nitrogen rates there. So this is a photo. This is a picture taken in middle of June, the first year at our Waseca site. We have turkey litter corn here on the left and bedded beef pack here on the right. And remember, we had aimed to apply the same nitrogen rate with all of these. And you could tell right away, just by looking at these, that the bedded beef pack corn was a little bit behind where the turkey litter corn was in growth stage and a lot of different metrics. Here's some aerial photographs. We actually did each of these treatments was replicated 4 times. So we had a strip where we had all the treatments, and then we had 3 other strips where these were replicated. So that's kind of what I'm showing here, just 2 of those strips. And then we had all the plots were randomized within each of these strips. So like here's our bedded beef pack. You notice that it's a little yellower and green. You can see a lot more soil between the corn rows. Overall, again, really showing us that there is probably a nutrient deficiency. If you compare it to our zero nitrogen fertilizer plot, it looks very similar. On the other hand, our swine plot looked really good. You can see less soil. The corn looks a lot bigger. Turkey litter looks really good as well. So that was taken in late June in 2018 at the Lamberton site. These are the same plots about a month later. And again, we can still see here's our bedded beef pack. It's light green compared to the corn nearby, which is much darker green. So again, we were seeing these nutrient deficiencies pretty early in the season. So I'm going to jump to harvest, and this is our yield for corn following soybean, first year of the rotation, manure had been applied. And this is averaged over all 4 site years. So remember, we have 2 sites in 2018, 2 sites in 2019, spread across Lamberton and Waseca. Corn yield in bushels per acre, 0 to 240 right here. Our first set of graphs show our manure source. Here's our finishing swine manure first, bedded beef pack second, dairy third, and this is our raw dairy. Our separated dairy is 4th, chicken layer is 5th, and our turkey is 6th. And then we have our next graph shows us the nitrogen rate curve, and you can see that as we increase nitrogen, it was slowly starting to level off. And phosphorus rate curve is this last graphic here on the right. And we did see a phosphorus response across all the sites, although it wasn't nearly as drastic as the nitrogen response. So in this case, nitrogen was the more limiting nutrient, which typically is what we see in most cropping systems. But what was interesting is that, swine, our chicken layer, and turkey manures kind of did the best, and they were pretty consistent over sites. The bedded beef pack consistently did the worst, and there's slight differences between dairy and separated dairy, but they were not statistically different. But they were kind of on the lower end. These were all consistent across all sites and all years. The thing that was different was this turkey plots. The first year in 2018, they actually yielded at both sites a lot higher than our second year. And what turned out to have happened is our turkey litter in the first year was a lot fresher. It had just come out of a barn. And then the second year, we got it from the same location, but they had unfortunately experienced a tornado. So they did not have any turkey production for the whole year. So the pile that we got it from had actually sat for the whole year. So we were calling it more aged turkey litter in that case. So we think that's why we saw a lot more variability in those plots, because fresh versus aged manure is going to be different in nutrient content. So the next thing we did is we wanted to look at nutrient uptake of the corn. So we harvested corn by hand. We went in and took some plants and then chopped them off about a foot or so above the surface. And we measured the nitrogen in the stalks, the cobs, and the grain. Added that all together to get how much nitrogen was taken up in pounds per acre. So you can see it ranged from 0, or y-axis is from 0 to 160 pounds of nitrogen. Our setup is the same: swine, beef, dairy, separated dairy, chicken layer, and turkey litter, and it compared to our nitrogen rate curve. So what's cool about this is because we have a nitrogen rate curve, we can develop an equation that predicts how much nitrogen uptake there was compared to how much nitrogen we applied. So we developed that curve, found the equation, and then since we know how much nitrogen was uptaken by the corn where we applied different manure types, so say we did swine, we could compare it to that equation and find out what the predicted nitrogen rate was. So this gives us our fertilizer equivalent value of the manured plots. So I summarized all that data in a table because we did it for each different manure type and each different year and found the averages. So on our table here, we have manure source, swine, bedded beef pack, dairy raw, dairy separated, chicken layer, composted manure, and turkey litter. And then we have our nitrogen fertilizer equivalent value. So our swine finisher on average, we are aiming to apply 140 pounds of available nitrogen. On average, we got 100. Bedded beef pack, again, aiming for 140, we only got 29. Raw dairy was 67. The dairy separated was a little bit higher at 73. So it suggests that that separation process increased the availability a little bit. Our composted chicken layer was 118 and our turkey litter was 81. If we take that value, that nitrogen fertilizer equivalent value, and divide it by the total amount of nitrogen applied, that gives us our availability factor that we used. So, for instance, for swine finisher manure, we only got about 46% of the total nitrogen applied was available on average. For bedded beef pack, it was 10%. Dairy raw ranged from 24 to 28% if it was separated. And then both of our poultries were about 34%. And just to show you what we assumed was available based on our current recommendations, you can see that what was available and what we assumed were very different things. So what about phosphorus? Well, we did the same thing. We figured out our phosphorus response curve, put an equation to it, figured out how much phosphorus was taken up by our plants, and then we could figure out the phosphorus equivalent value. The one thing I do have to mention though is that, remember our bedded beef pack, the corn looked really stunted. It just didn't grow as big because it was nitrogen deficient. So if it was already nitrogen deficient, this means that it didn't take up as much phosphorus as was available, right? So just because this is the fertilizer equivalent value that we got, it doesn't mean that it's like it was limited, that they wouldn't have taken up more phosphorus if they had sufficient nitrogen. So here's our phosphorus equivalent value. Swine finisher manure was 33 pounds of nitrogen per acre. Bedded beef pack was 21. Raw dairy was 34. Dairy separated was 38. So I thought that again was interesting that it had slightly more phosphorus available. Chicken layer was 77 and turkey litter was 47. What was interesting, and I'm going to back up here and show you these slides again, is that notice most of our phosphorus peaked out around 25 pounds of phosphorus per acre. And this is where we added 120 pounds of phosphorus. So we were getting more than sufficiency with a lot of these manure types. The one that was maybe not quite as sufficient was the beef manure. And we had talked about how the yields were a little bit lower with that, so they probably just didn't take up as much phosphorus. Now, if you look at how much P was applied versus how much P our crops took up, this is where things started getting interesting. Our swine finisher manure, our crops took up 145% of the nitrogen applied, which means it started taking additional phosphorus out of the soil. And you may think, well, that's interesting. How did that happen? We don't actually know, because obviously we know how much we applied. It shouldn't take up much more than that, but we do know that the soil can provide some. One of the interesting things that has happened recently with swine manure is that, recently, within the last decade, they started adding phytase to the diet. And phytase is an enzyme that makes phosphorus more available, especially from plant matter. So we're wondering, and I have to talk to my animal scientists and see if this is something that could happen, but we're wondering if enough phytase is added to the diet such that the hogs are excreting it unused so that it can get into the soil. We're wondering if we're actually increasing the availability of phosphorus with swine manure to the point where we're seeing soils that have a lot of swine manure application history being mined of phosphorus. And I've actually anecdotally heard of farmers talking about this where they feel like they're not getting as much phosphorus from their swine manure as they used to. They used to be building up their soils with phosphorus, and these days they feel like they're mining it. This might indicate why that's happening, but again, I have to talk to my animal scientists colleagues to see if phytase can in fact be excreted out of the back end of the animal. As far as the other ones, another interesting one is if you remember our chicken layer, the corn took up the most phosphorus from there, 77 pounds per acre, but it still only took up 39% of the phosphorus that was applied. Again, showing you how much phosphorus we applied with this composted chicken manure. So it really illustrates that phosphorus is going to be variable across manure types, and that there are certain manures that if you're using these as a full nitrogen rate, you are going to build up your phosphorus levels pretty quickly. So we repeated this the second year, and we did not apply nitrogen or phosphorus to the manure plot. So you can see yields were pretty low, less than 80 bushels per acre. Again, we have our manure sources in the same order across the bottom. Here's our nitrogen rate plot yields. Here's our phosphorus rate plot yields. Interestingly, in our second year, we did not see as much of a phosphorus response. About 30 to 60 pounds actually maximized our yields in this case. So that was kind of an interesting thing that happened. Now, I just did the same thing. We looked at nitrogen uptake of the corn, phosphorus uptake of the corn, and I summarized those results in the table. We have nitrogen fertilizer equivalent value for the second year, fertilizer equivalent value divided by the total amount applied that first year. Same with the phosphorus equivalent value and the percent of field available after it was applied. You can see nitrogen was pretty low, ranging from 7 was our lowest up to 18 or 19 pounds of nitrogen per acre. It wasn't 0. We know that manure usually releases nitrogen further than the first year. And we definitely saw that. The one that was surprising was the swine finishing manure was actually a lot lower than expected. We expect about 25 or 15% of swine manure total nitrogen to be available that second year. We were seeing much lower than that, about 3%, versus all the others were about 5 to 6%. They were pretty consistent across sites and across years. For phosphorus, again, our composted chicken layer was still supplying a lot more phosphorus than the other manure types, about 17 pounds, versus the others were like 1 to 5. Turkey litter supplied 10. But overall, the amount of phosphorus applied, well, that was a lot more variable than the nitrogen. You see nitrogen ranged from 3 to 6% versus the phosphorus ranged from 4 to 14%. What about the third year? Now, this is just averaged over 2 years. We don't have the fourth year nitrogen and phosphorus uptake in yet because we just harvested that corn. So we still have to get that data back. So this is just averaged over 2 years. But again, you can see yields were very low, less than 80 bushels per acre. Here's our nitrogen rate curve and our phosphorus rate curve. Again, we saw a very similar thing where phosphorus was not super responsive. Overall, our nitrogen fertilizer equivalent value ranged from 6 pounds up to 33. We actually saw a little bit of a bump that third year from the composted chicken layer. Remember, anytime you're composting stuff, that really makes it a much more slow release nitrogen source. So that's why we did end up seeing a little bit more nitrogen, but it was still only 4% of what we applied. So anywhere from 1 to 4%. We are not seeing a lot of third year nitrogen credits from these manure types, at least in these 2 years. We'll see what the second 2 years bring us. For phosphorus, anywhere from 0 to 7 pounds of phosphorus could have been credited, and that was from 1 to 11% of what was applied. But overall, again, still much more variable than the nitrogen. So it's kind of interesting to see the differences between nitrogen and phosphorus. So take-home messages. I want to reemphasize that 2018 and 2019, when we applied this manure, were very, very wet. This manure was spring applied, so we did not get a chance to fall apply just due to the way this research was funded. We spring applied, and nitrogen was probably lost. We think that some of these manure types may have released more slowly because of the wet conditions. And when they did release, it was, well after the period when corn was taking up the nitrogen. So during very wet years, we expect slower availability. Where did the nitrogen and phosphorus go? We're thinking that because of the low first or second and third year availability of the nitrogen, that it likely was lost in these particular studies. It was either denitrified because of the wet conditions, or it was leached. We do have a lot of in-season, post-harvest, and pre-season soil samples that'll hopefully add to our story about where this phosphorus went or where the nitrogen went. We have soil samples down to 2 feet, so we should be able to see, was there a lot of residual nitrogen before the second and third year started, or was it already gone? The one thing that I do also want to point out is that that variable P uptake, how it ranged a lot more greatly, that means it's going to be really important to soil sample after manure has been applied in those fields because of the variability, and because a lot of people are applying at a nitrogen-based rate, but phosphorus can vary greatly as you're moving out your manure. So whether it's a solid or a liquid, phosphorus can vary pretty drastically within a storage, and that means it can also change drastically as you're applying it across the field. So soil sampling is going to be really important in manured fields for phosphorus particularly. So where do we go from here? We're wrapping up the last part of our study, so we need to figure out, look at our soil samples and that sort of thing. I'd like to take this a little bit further though. We looked only at spring application. I'd like to continue this research and look at fall versus spring. Maybe it's that these manures that have high organic matter, like our dairy and our beef, maybe fall application gives them more time to release the nutrients that would synchronize better with crop uptake. Maybe they don't, maybe that's not a thing, but I'd like to look into that to see if there is a difference. 2, consider alternate methods of determining nitrogen availability in manure. This is one of the things that we're looking at potentially doing. I want to kind of revisit our nitrogen cycle. If you remember, there's 3 different forms of nitrogen in the soil: your organic nitrogen, your ammonium nitrogen, and your nitrate nitrogen. Plants are only taking up the ammonium and nitrate forms. Ammonium can be lost through a gaseous process. If it's on the surface and it's windy and it's warm, it's a chemical that can be lost and it can convert to gas pretty easily. If it's mixed in with the soil, we don't worry about that as much though. Nitrate, on the other hand, can be easily lost. It can turn into a gas through microbial action, or it can be leached. So we kind of favor ammonium when we're thinking about applying nitrogen sources to soil. When we're thinking about manure, we're not getting nitrate. Typically, it's stored in kind of anaerobic conditions. So we're going to get the organic nitrogen form and the ammonium nitrogen form. The difference is the species, and I kind of alluded to this when I was showing you some of that nitrogen data earlier. Here we have our manure nitrogen distribution. We have different manure types, solid versus liquid. And then from the top to bottom, we have our different species. So for liquids, swine, dairy, beef, and for solids, swine, dairy, beef, and poultry. The red part of the bar, or the left side, shows you the percent of inorganic nitrogen of the total nitrogen. So how much of it is in the inorganic form? The yellow bars on the right side shows us the organic nitrogen portion. You probably noticed 2 things right away. One, and I talked about this earlier, one, the liquids have a much higher proportion in the ammonia form. Our swine manure is averaging 75% in the ammonia form. So that means, one, it can transform into nitrate pretty quickly once it's in the soil. So we do have to consider that when we're thinking about timing for application. And it acts much more like a fertilizer nitrogen source. Our dairy and beef, when they're in the liquid storage systems, they're averaging a little over half ammonia, but it's roughly half and half. So we do need more time for this organic nitrogen to break down. Compared to our solid manures though, like the poultry manure has the most ammonium and it's still very small. It's 26% nitrogen. And that actually, remember that poultry also just has a lot of nitrogen. So even though it's only 26%, it still has a lot of ammonium. I don't know if any of you have ever dug around in poultry piles. I have, and my staff have. That ammonia waft will like knock you over if you get a little too close to it. It still has a lot of ammonia, but it's still a low proportion of the total nitrogen that's there. Swine, beef, and dairy solids are less than 20%. Even beef is 11%. So these need to be treated differently when we're thinking about our manure availability. If you remember, our current recommendations treat liquid beef and solid beef the exact same, even though they have drastically different ammonia concentrations. So moving forward, and we still need to work on this, but moving forward, we're likely to move to a new system where we're going to look at ammonia that isn't lost during application. That's where the application method is still going to come into play. We'll add that to the organic nitrogen that's released during the year. From there, we'll have a more kind of site-specific or barn-specific nutrient availability, nitrogen availability factor. Right now, we just get total nitrogen, we multiply it by 1 factor, and we call it good. But I think we need to have a little bit more nuance in those recommendations to kind of deal with some of the differences we see across manure storages. However, some of this still needs to be worked out. How much organic nitrogen is released in the year? We still need to look into the literature and try to figure that out. So still a work in progress, but just kind of heard it here first. This is probably one of the changes that's coming in the next few years. So we talked about the first 2 places where we're going. Going to keep doing research, consider alternative methods of calculating nitrogen availability. I'd also want to start looking into the idea that maybe since nitrogen is so variable in manure that we need to start adjusting practices as needed. One of the ways that we could potentially do this is using a base nitrogen rate. And I think we talked about this earlier with some of the economics, is if we have a base nitrogen rate, could we use a pre-sidedress nitrate test or some other indicator where we could apply the rest of the nitrogen as needed? Because in some years, like in our wet years, we saw that there was less nitrogen available than expected. If the pre-sidedress nitrate test told us that, we could then apply more nitrogen. In years where we know that more nitrogen is released from the manure, nice, evenly moist years where it's nice and warm, or we might get more availability than expected, maybe we don't need to put on that nitrogen then. Again, this gives us more of that flexibility, and we might be able to more specifically apply nitrogen to meet our needs rather than just saying, it's just manure, no one cares about it, let's not give it any credit anyways. So we're hoping that we can kind of break these down and think more about how to move on forward. So that is all I have. Thanks to our funding sources, the Agricultural Fertilizer Research and Education Council, my crews, especially SROC crew and the Southwestern ROC crew as well, and my staff for putting up with dealing with trying to find 6 sources of manure and getting them all to the same location so that we could spring apply them all at once by hand, which was a lot of fun. I think I still might have back problems from that first year that we did this and didn't have enough help. Contact info is here. Here's my email. Follow me on Twitter at ManureProf. If you're interested in seeing our work on manure and sugar beets or our side dressing projects, check out that link there as well. We're trying to post some updates on those research projects too. So I think with that, I should have time for questions. Plenty of time. All right, so do I have any in-person questions first? In the back, yes. Yeah, so the question was, it's getting harder to sample swine manure, particularly because it's under barn. And are there there's different sampling methods? Is there data to show that there's differences in that? There is. I was just reading a paper out of Iowa where they were doing different sampling with barns. And it really depends on how well it's agitated. One, because if you are sampling with a PVC pipe and you're trying to get samples before you go, you have to know like how deep that pump goes, because if it's not getting all the stuff at the bottom, but you're sampling all the stuff at the bottom, then you're going to have different results than when you mix it and then pull it out. So if you know how deep that is going, you know how, if you have a custom applicator and you know how far they're getting that pump in there, you might have a better idea of where to actually sample in your pit. Otherwise it might be different. But they're showing that well agitated pits have much less variability as they're being drawn out. In the case where you can't agitate that well because the manure is too high, you don't want to worry about foaming issues or harming the pigs, there is going to be variability as it's coming out. Right now, we're thinking that as it's agitated and sampling as it's applied is probably some of the least variable that you'll see. You will want to potentially make adjustments though. So once you do your sampling, you'll have already applied, will want to go back and recalculate your application rates as needed, and then potentially adjust your fertilizer application rates as well. Hopefully, I don't know if that answers your question or not. Other question? Sure. So one of the question was some of the onboard nutrient sensing for manure, which is primarily from John Deere. I think there's some other operators that are in Europe right now. I don't know if they're coming over to the US anytime soon. So first question was, have I worked with it? I have not. I've seen it in action. I went down to John Deere and got to see how it operated. And there is a researcher in Wisconsin, however, that is working with it, Rebecca Larson. She's doing some on-farm testing. And right now, they're feeling like it's fairly accurate. There's some tweaks that they want to make with it because they want to make sure, like they're seeing differences as they're pulling stuff from the barn for sure. So it is picking up those differences. They want to work with some bigger farms though. They've been working with smaller plots and they think they're just not working with kind of the volume of manure that they need to for this to be making more of a difference. So there is that. I think they just posted some of their talks. So I just saw her talk at the Wisconsin agribusiness conference. So if you get a chance, look that up and she'll have some information on that. As far as accuracy, I'm familiar with the NIR technology. With nitrogen, it's actually pretty decent with manure. As long as it's not too liquid or too solid, right? It has to be in that sweet spot. I think they're usually saying between 2 and 8% solids is where it works best. With the nitrogen, it's actually fairly accurate within the like 90% accuracy. With phosphorus, it's not as accurate. The technology is actually physically measuring carbon, nitrogen, hydrogen ions in the manure. So nitrogen, that's why it's so good. With phosphorus, it's kind of correlating it with the solids content. So they're thinking it's only about 70% accurate, but I mean, still, if you're only taking one sample from a pit and then trying to estimate the rest of the pit, this can have its place, certainly. And then what was the third part of the question? Okay, calibration. Yeah, they do all need to be calibrated. And that's one thing, one of the reasons why it's taken its time coming from the European market to the US market, because we do have different like animal production systems here and different storage methods. So I think they have been taking their time to try to calibrate those to the manure systems that are here in the United States, but it takes time. All right, any other questions? Looks like I have quite a bit racking up here online. All right, so when will RECs be updated? A lot of farmers are under fed and state regulation for how much more they can apply based on current RECs. And if they are this far off, they need to be updated sooner rather than later. Yes, we are certainly working on that. One of the things that I mentioned is that this was applied under really wet conditions. We've always known that the availability factors are just an average and they kind of account for wet years, dry years, et cetera. So some of the stuff that we were really off on were obviously really wet conditions. So we're hoping to continue some of that research. One of the things that I'm hoping to do sooner rather than later is thinking about the ammonia concentrations and adding that into the availability factors. So hopefully we'll be getting that out soon. I don't know if we have enough data quite yet to do it this year, but hopefully sooner rather than later. Yes. Yeah, so the piggybacking on the last comment, the comment was that some of this data definitely needs to be shown to some of the regulatory officials. We're trying to work with them. I think they're aware of our research that's going on, and I try to talk to everyone that I can that's involved in the manure industry to see what research is needed too. So we're trying to update it as fast as we can, but it takes time. I'm the first one to be doing strictly manure research since I think I started in 2017. My first field season was 2018. So sometimes it just takes time to build up that data to be able to say, this is what happened. I mean, like the data that I showed here was just 4 sites over 2 years. So it's also like, is that a trend or is it just what happened under these conditions? So I'm trying to, and we're working with regulatory officials as much as we can to try to get that well known. So what was the bedding in the beef pack? Does it make a difference? Straw, corn stalks, old grass hay. We actually used 2 different beddings, manure sources in this particular study. The 1 year was more of a wheat straw and the 1 year was corn stalks. I think it can make a difference if you think about like carbon to nitrogen ratios. If you have something that has a lot of carbon in it, like you're using sawdust, that's obviously going to release differently than something like corn stalks. So sometimes if you can get a good idea of what the carbon to nitrogen ratio in your manure is, That might be good. It's difficult to test though, because, you know, when you send something to a lab that has a lot of bedding in it, it's hard to get, you know, how much is bedding versus how much is manure. But trying to think about that can potentially help. How was the manure and fertilizer incorporated? We tilled it under, disked it under shortly after application in all of the different years. So we spread it, all of it was broadcast, and then we incorporated it pretty quickly. Any liming events? We did not lime in these particular cases. All of these soils were above 6.5 or so, so we did not need to lime in any of these cases. Restate the organic and inorganic nitrogen in the composted chicken litter. In that case, I would have to look at my data. We didn't have composted chicken layer specifically in our lab data, because they just tell us if it's chicken layer or poultry litter. Poultry, they don't tell us if it's litter or composted layer or what it is. So I don't have it in the composted stuff. I can look at my data though, and if someone, whoever said the question wants to email me, I can try to get that back to them. Next question, how much additional work is needed to measure the amount of sulfur in manure while you're testing nitrogen? That's a good question. Right now, there's only capability really to measure total sulfur. So in that case, it's usually the same instrument. In most cases, it's a combustion analyzer. So you take a small amount of manure, combust it to get nitrogen, and then it would also potentially get sulfur. Not all labs have that equipment though. So it really depends on the lab that you're doing. And usually they will charge extra for sulfur, but that's not always the case. So certainly talk to your local lab and see if they have that availability. How might nitrogen recommendations change for fields that receive manure year after year versus those that do not? That's another great question. Right now, we are recommending that you take at least a second year credit for your manure. So if it's manured year after year, you would always have that second year credit from the year before. So as long as you're crediting that nitrogen, it should be fairly similar, but it is a great question. We would assume that, you know, soils that have a manure history probably have different microbial populations that live within them. So there might be differences in nitrogen cycling. Right now, I actually don't know of anyone who's looked into this to see if there's differences in the nitrogen crediting for manure history fields versus not. Any suggestions for growers trying to do their own field experiments with manure application? Yeah, definitely. I think one of the big things is to think about randomly, if you choose a couple different rates that you want to apply, you want to randomly choose different strips across your field. Try to do at least 3 different strips of each of your different, you know, treatments that you want to do. For instance, if you wanted to apply different manure rates or use different equipment for injecting, trying to, you know, flip a coin, decide if you're going to do the one treatment or the other treatment across that field can help you do some randomization so that you're not picking the bad or the good parts necessarily with your own bias without thinking about it. And then it can give you some good ways to compare things. One thing that I found out the hard way is if you're doing on-farm experiments, make sure your manure application equipment is the same width as your harvest equipment, or else you're going to potentially be harvesting into the next strip and not be able to see some of the differences. You had the question, Jeff? I didn't pull this. I can figure that out for you later at some point, Jeff. Oh, sorry. The question was, is there a difference between grain pea removal and total corn pea removal when we saw that soy manure had removed more pea than the other manure types? I didn't look at it specifically by grain, but we do have that data separated out, so I could at some point and get back to you. And I think the last question is, any work looking at secondary or micros or strictly NMP? Currently, we are just strictly looking at nitrogen and phosphorus, mostly because that's getting the most attention recently. We would like to look at sulfur availability, particularly in the future. And we do get questions about micros, particularly zinc and copper and those sorts of things. But no plans to look at them at the moment. Unfortunately, I'm just one person, and it turns out I'm been keeping pretty busy with all the manure work that needs to be done in the state. So we're slowly getting around to some of the stuff. I think that's it. I feel like I just went through the ringer there. Whew.